Our next problem is a very important problem of liquid solutions. We are given that the molar volume of liquid benzene, whose density is given, increases by a factor of 2750 as it vaporizes at 20 degrees Celsius. And in the same way, when liquid toluene is vaporized, its volume increases by a factor of 7720. A solution of benzene and toluene has a vapor pressure of 46 millimeter of mercury at 20 degrees Celsius. We need to find the mole fraction of each of these benzene and toluene in the vapor present above the solution. So let us first try to find out the initial volume. Since we have molar volume, so we have 1 mole of each of liquid benzene and liquid toluene. 1 mole of benzene means 78 grams of benzene, and hence the V initial for benzene is 78 divided by the density, which is given to be 0.877. This is in ml. So the volume, or rather the new volume after the vaporization, is 2750 into this in ml, and this comes out to be equal to 244.58 liters. Similarly, the final volume of the vapor of toluene, when liquid toluene converts to vapor of toluene, is V final for toluene, this is for benzene, is, since it increases by a factor of 7720, so it is equal to 7720 into the initial volume, which was equal to weight of toluene, which is molar weight, it is 92 grams of toluene, divided by the density of toluene, which is given to be equal to 0.867. This gives the final volume of toluene to be equal to 819.19 liters. Now, since considering these two as ideal gases, so we can apply the ideal gas equation. PV is equal to nRT. We have the temperature to be equal to 300 Kelvin. We have N, we have R, and we have the volumes. So we can find out the pressures for toluene and benzene to be equal to, let us say, the pressure for benzene vapor is PB naught. It is equal to nRT by V. This N is equal to 1. On solving, this comes out to be equal to 0.09 atmospheres. And if for toluene it is PT naught, then for toluene also it is equal to 1. This is equal to 300 Kelvin, and this volume for toluene we calculated to be equal to 819.19 liters. So the pressure for toluene comes out to be equal to 0.029 atmospheres on putting all the values in this formula. Now it is given that a solution of benzene and toluene has a vapor pressure of 46 millimeters of mercury. So if the total pressure is 46 millimeters of mercury, let us say it is 46 upon 760 atmospheres. Since these are both in atmospheres, so we convert this also in atmospheric pressure by dividing by 760. So this is equal to 0.06, and this is equal to PB naught into the mole fraction of benzene in the liquid solution plus for toluene into the mole fraction of toluene in the liquid solution. Mind you, this XB and XT, as we did earlier, are the mole fractions of benzene and toluene in liquid solutions and not in the vapor state. Now we know the value of PB naught, we know the value of PT naught, and we know the equation XB plus XT is equal to 1. So putting 1 minus XB in place of XT, we get the entire equation in terms of XB. On solving this, our XB, or the mole fraction of benzene in liquid solution, comes out to be 0.45. So the mole fraction for toluene will be equal to 0.55. Now our final job which is remained is to find the mole fractions of benzene and toluene in the vapor state. In vapor state, the mole fraction of benzene will be equal to the pressure of benzene, which is 0.098 divided by the total pressure, which we calculated to be equal to 0.06, into the mole fraction of benzene in liquid state. This is the mole fraction of benzene in the vapor state. This comes out to be equal to, on solving, this comes out to be equal to 0.735. Hence, an important thing to note in this problem is that for using this formula we have to be very careful, because these are the mole fractions of benzene and toluene in the liquid state and not in the vapor state, and hence our final answer for the mole fraction of benzene in the vapor state is 0.735, and that is our final answer.